Quiz review. Move this over. That's wrong. Okay, here. So James has 4/5 of a chocolate bar. He wants to share among 4 of his friends how much they each get. So let's draw it out. You get 1, 2, 3, 4, 5. We want to shade in 4. Right? 4/5. This is what he has. And he wants to share among how many people? 4 friends. What kind of question is this? 4/5 divided by 4. Really? What was I thinking? Well, friend A will get this, right? Alex will get this, Boris will get this, Charlie will get this, and David will get that piece. So what did they each get? Well, they each got 1/5. So if you had 4/5 and you were to split it among 4 friends, they each would get 1/5. So the sentence would be, each friend received or got 1/5 of a chocolate bar. Wow. I don't know why I made this question so simple. Well, we're moving. Carla has 3 gallons of gas left in her car. So, 3 gallons. So this is what, let me display this as 1 gallon. I'll use this as her second gallon. And I'll use this, I'll put a third gallon over here. So each bar represents 1 gallon of gas, okay? She uses 2/3 of a gallon per day. How many more days can she drive with 3 gallons of, so this is what she has, 3 gallons. And every day she uses this much gas, 2/3 of a gallon. So whether she goes to work, wherever she's going, she uses this much gallon every day, 2/3 of a gallon. Actually, she doesn't drive that far, 2/3 of a gallon. It's about maybe, well, depending on the car. Anyways, so we want to split into what? We want to split everything to thirds, right? So she has 3 full gallons, and let me shade this to represent that she has full 3 gallons. Another gallon of gas, another gallon of gas. So every day she uses this much. So if she has 3 gallons, how many days can she drive? Well, this she would use in 1 day, so it would be 1 day, 2/3 of a gallon. Another day she would use another 2/3 of a gallon, so that'd be 2 days so far. She will then use these 2/3 as her third day, and her fourth day she will use this. So for sure she can drive this for 4 full days. And then the next one, can I put these 2 in there? Can I make another group of 2? I can't. I can make a group of 1 out of the 2 I was trying. So she can drive for 4.5 days. For the following 8 questions, use a model. Yikes. And using the same denominator method. Okay, so we're going to use a model and same denominator. So in here, with this one, you know what I'm going to do? I'm going to put this over 1, like that. 6/5 of 3. And then I'm going to find the LCM, which is 6. So I'm going to change this to 6 divided by something over 6. And this is going to stay the same, which is 6, 5, 6. And this one is times 6, so the top will be times 6. And that's going to give me 18. If I do it with the same denominator method and I find the same denominator, I can cross the 6 is because we're talking about same units, and we're going to write it as 5 over 18. Let's see if that translates to our model. And that model, I'm going to draw this over here, 5, 6. So 5, 6 is something that's broken up into 6, whereas I have 5. 1, 2, 3, 4, 5, 6. Let me shade in 5. And that's being divided. So, and the other one is what? 18 over 6? Yikes. So 18 over 6 would be 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 18 over 6. Okay, keep in mind what that is. Try that again. 6 over 6 plus another 6 over 6 plus another 6 over 6. So 18 over 6. So how many times can these 18 fit in here? Can't fit all these 18 in here, but I can surely fit 5, right? 5 of these can fit in here. Out of how many I was trying to fit in? 18. Or another way of saying this is how many groups of 18 can I make out of 5? I can't make a group of 18, but I can make a group of what? I can make a group of 5 out of that what I was trying to make, out of the 18 I was trying to make. That's why this answer and that answer, whichever way you choose to do it, matches. Again, this is a 2. It's a whole number. I'm going to put it over 1. Find the LCM. The LCM is going to be 5. This is going to stay as 1. It's times 5 here, times 5 at the top. And we're going to get 10 over 1. Cross and cross, and then we get 10 over 1, which is just simply 10. So 2 divided by 1/5, you can think it as I have 2 of something, and then want to divide it by 1/5 of a person. That's not really going to work. Or how many groups of 1/5 exist in 2? So let's see how I draw this. 10 over 5 is something cut up into 5s. 1, 2, 3, 4, 5. But I'm going to need 10 of these, 10 1/5 pieces. Let me shade that. So there's 5 over 5, 6 over 5, 7, 8, 9, 10 over 5. And I want to divide that. I want to see how many groups of this. 1, 2, 3, 4, 5. How many groups of ones can I make in here? So if you see it, well, I can make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can tell that this fit inside that 10 times. And you know that our answers match right here. Okay. How many 3/4 are in 10/4? So careful here. I think I purposely wrote this so that you can you should be able to interpret that the division problem. It's written like this, right? How many 3/4 exist in 10/4? This one, there's not much to do. That's already same denominators, so we write it as 10 over 3. That's improper. That's going to change into 3 goes into 10 3 times, 1 left over 3. So let's see how that translates to this. 1, 2, 3, 4. 1, 2, 3, 4. And hopefully you realize why we need 3 bars. So here is 4 over 4, 5 over 4, 6 over 4, 7, 8 over 4, 9 over 4, and 10 over 4. I need 10 1/4 pieces, and I'm going to divide that by 3/4. 1, 2, 3. Let me represent my 3/4. So how many times can 3/4 fit into the 10 out of 4? So I'm making groups of 3, right? I can make a group of 3. I can make another group of 3. I can make another group of 3. So for sure, these 3 will fit in there 3 times. And as you can tell, if I try to fit these 3 on the last one, not all of them will fit, but one of them will fit out of the 3. And I get the same answer I got with the other method. How many 8/5 are in 3/5? Well, again, let's write this. That's how you would write that, because how many 8/5 exist in 3/5? Let's draw it out. Let's show our 3/5. Show what I have. So that's the first thing you should draw is what you have. Here's your 3/5. And let's draw our 8/5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 8/5 is 5 over 5. 6 over 5, 7 over 5, 8 over 5. You can clearly tell that 8/5 will not fit in there. All this will not fit in there. I'm trying to make groups of 8. I can't make a group of 8 out of 3. But out of these 8, how many can fit in there? If you want to think of it that way, well, out of the 8, I can fit in there 3. Out of the how many you were trying? Out of the 8, If you do the other method where we cross out same denominators, this crosses out. We write the top as a fraction, we get 3/8. This and this, same exact answer. Why did I give you so many easy problems? 7/8. Half, half, and half. Half again, half again, half again, half again. We have 8s. Then over here, 1, 2, 3, 4, 5, 6, 7, 8. We're going to shade 2. Right? So how many groups, right? We're trying to make how many groups of 2/8 exist inside 7/8. Well, there's a group of 2/8, another group of 2/8, another group of 3/8. So with sure 3. And if I try to make another group of 2, I can't, but I definitely can make 1 out of the 2 I was trying to do. Let's see if the other method shows the same. It crosses out. Let's write the top as a fraction. 7 divided by 2, and obviously 2 goes into 7 3 times. 1 left over 2. Next one, 3/7. Let's show what we have. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I drew one more. And 3/5 is 3/7. I'm sorry, is this. The other one is 5/7, 3, 4, 5. Again, just with the models, how many groups of 5 can I make inside of 3? I can't make a group of 5, but I can make a group of 3 out of the 5 I was trying, right? Out of this group of 5. If I wanted to circle 5, I can't because there's no 5. There's only 3. So I made a group of 3 out of the 5 that I wanted. The other method, you can cross it out, right? Because the same denominators. Let's write that as a fraction. And you get the same answer. Okay, again, so 5/3. So here is 1/3, 2/3, 3/3. So I need another thing, another bar, cuts in thirds. So 1/3, 2/3, 3/3, 4/3, 5/3. So that's 5/3. 5 pieces of 1/3. Okay, each box is 1/3, so I need 5 of them. And then here, I want to see, I'll shade in 2/3. How many times can 2/3 fit into 5/3? Well, these two can fit in here 1 time, can fit in here 2 times for sure. If I try to fit these 2 again in here, they won't. One of them will, add up to 2. So 2.5 times. How many groups of 2/3 exist in 5/3? 2 and 1/3. 2.5, I'm sorry. Cross and cross, you write that as a fraction, 5/2, and that changes to a 2.5 as a mixed number. 4/5 divided by 1/5. What was I thinking when I did these problems? 1, 2, 3, 4, 5. Wow. 1, 2, 3, 4, 5. All right, so 4/5 is this, right? And then 1/5. Again, you want to see how many 1/5 exist in 4/5? Well, there's 1/5, right? One group of 1/5, another group of 1/5, another group of 1/5, and another group of 1/5. And the answer is 4. This way, cross out to 5, so you write 4/1, and 4/1 is 4. We're not modeling on the next ones, only if you want to. Okay, so we need to find the LCM. The LCM of 5 and 6 is 30, right? How did the 5 become a 30? So it's times 6 here, times 6 on top, you get 24, times 5, right? And then times 5 on top, you get 5. So same denominators, we can cross. We can think of this as 24 divided by 5, and then 5 goes into 4 times, 4 left over 5. This one's much easier. LCM 8 and 12. What's the LCM of 8 and 12? Is 24. Okay, if you don't use the LCM, your answer will not be incorrect. It will just be bigger. Eventually, you're going to have to simplify. You get the same answer. 8 times 3, right, gives you 24, so it's 21 on top, because 7 times 3. And 12 times 2 is 24, so times 2 on top gives you 10. Cross, I'm going to get 21 over 10. I need you to write this fraction over here, okay? Just don't go straight. And then it's much easier to look and now change that improper fraction to a mixed number, which is 2 and 1/10. 10 goes in 21 twice. 1 left over 10. We did this today, mixed numbers. So mixed number, I want you to change that to an improper. So 5 times 2 is 10. You get 13 over 5 divided by 2 over 7. Now you can find the LCM, which is 35. And both denominators change, so you got to make sure you change the numerators. So this is 5 times 7. So times 7 on top, which is 91. How did the 7 become 35? Times 5, and then times 5 on top, which is 10. Common denominators, yay, 91 over 10. 10 goes into 91 9 times, 1 left over 10. Final answer. Again, we change this to an improper. 3 times 4 is 12, plus 2 is 14 over 3, plus 4 times 1 is 4, plus 1 is 5 over 4. The LCM is 12. Right? How did the 3 become a 12? Times 4, so I multiply the top times 4, gives me 56. 4 times 3 at the bottom, so times 3 on top is 15. Cross and cross, this should not be a plus sign, it should be a division sign, I apologize. And I get 56 over 15. No idea what that is. 56 over 15, 15 going to 56, 3 times, yes. Yeah, which is 45, 11 left over 15. Okay. So here is a word problem. So he has 5.5 cups of sugar. Each banana bread she's making requires 3/4 cup of sugar. How many banana breads can she make? I used to like banana bread. So here's our expression. 5.5 divided by 3/4. Okay, so we're going to change this to a mixed number, improper, I'm sorry. 2 times 5 is 10, 11 over 2 divided by 3/4. The LCM obviously here between 2 and 4 is 8, so I'm going to change both of them to 8. I'm sorry, not 8, to 4. Okay, the LCM between 2 and 4 is 4. So this one's already a 4, so that we can just write 3/4. The 2 became a 4 times 2. I multiply the top by 2, I get 22. Cross and cross, I get 22 over 3, which gives us 7 and 1/3. Okay. Dan has 2 3/8 pounds of hamburger meat. I haven't had a hamburger in ages. Each hamburger is going to needs 2/5 pounds of meat. Does he have enough to make 8 hamburgers? I have no idea. So let's see. This is what I have. All right. The first number is what you have. I have this much, and I want to see how many 2/5 exist in 2 3/8. Okay. And that will give me the number of burgers I can make, because each burger requires 2/5 of a pound. So let's change this. 8 times 2 is 16. So it's times plus 3 is 21. So it's going to be 21 over 8 divided by 2/5, right? And we're going to find the LCM. The LCM is 40, right? How did the 8 become a 40? Times 5. So on top is times 5, and that gives us 105. How did the 5 become an 8? A 40. It's times 8. Times 8. 2 times 8 is 16. Our denominators are the same. We can cross. We get 105 over 16. How many times can 16 go into 105? 6 times is 96. 7 times would be to my, so it's, I'm going to say 6. 6 times 16 is 96. 9 left over 16. So, does he have enough to make 8 hamburgers? No. He has enough to make 6 hamburgers and 9/16 of the next one. So 6 regular burgers, full size or 2/5 of whatever, 2/5 pound hamburgers, right? And then the other one, maybe a little bit more than half that he can make. Um, so I will definitely use the examples we use in class. So make sure you go over that, all the sheets, all the handouts. And the bonus word. Ugh. You know what? There's a funny story. I believe it was Burger King. McDonald's came out with quarter pounders, right? Quarter pound. And it's called a quarter pound because the hamburger patty, right, weighs 1/4 of a pound. That was McDonald's. Now, Burger King decided to come up with, I don't know what the name was, but they used 1/3 of a pound, right? Thinking Americans would love this because it's more meat. But it failed. The 1/3 pounder hamburger the Burger King tried to introduce, this was a while ago, it failed because people thought that 1/4 of a pound was bigger than 1/3. Okay, that's why the 1/3 pounder from Burger King never took off. And the quarter pounder, 1/4 pound, still alive today, still kicking, right? A lot of people still buy it. And all because of this 3. People thought that this was less than 1/4. Funny story. Okay, that's it. So your bonus word might be Burger King, or I might even ask you about this story.